Alright, so this video is going to be dividing with exponents. For most of our cases here, we're going to show division as a fraction. So here we have x to the power of 5 divided by x to the power of 2. And once again, I'll show you this all written out, expanded, see if we can find a shortcut instead of writing all this stuff. So x to the power of 5 is x times x times x times x times x. And this is all going to be divided by an x and another x. What's going to happen? Let's think back to fractions. When you have the same number in the numerator and the denominator, what does that equal? Like here, x over x. Well, isn't that equal to 1? So in fact, this x on the top and x on the bottom, they're going to cancel each other out. Kind of like when you solve equations. X divided by x just makes 1, or it doesn't really do anything, because now 1 times the rest of this stuff, it's just the rest of this stuff. So it's like it goes away. Same for here. You got x over x. Well, anything over itself is 1. So these two will also cancel each other out. So what's left over? I can't cancel anything out, so I see what's left over. X times x times x. Shown short notation, that's x to the power of 3. Now, is there a shortcut that I can go from here with a 5 and a 2, and somehow I get a 3? I don't know. Let's try another one and see if we can figure out what the rule is. So what if I give you I don't know, x to the power of, how much is x over x to the power of 4? If I write this, this is x over 4x's. What's going to happen? That x on the top is going to cancel out with one of the x's on the bottom, because that makes 1. And I'm left with, am I left with nothing on the top? Oh, maybe I'll come back to that. Down on the bottom, I got x times x times x, which is x to the power of 3. On the top, it seems like you have nothing, but remember, this became a 1. So I'm not going to write nothing over here. I'm just going to write 1. This x over x was a 1. I didn't write it over here because x to the power 3 over 1 is just x to the power 3. Here, you need the 1 on the top. You can't have a fraction with just something on the bottom. So we get x to the power 3. If we look back at these, with a 5 and a 2, I got a 3. With this one, when there was no exponent, this was a 1. With a 1 and a 4, I got a 3, but this time it was on the bottom. The shortcut for these, like when you're dividing with exponents, what are we going to do with the exponents you see? Dividing with exponents, we're going to subtract the exponents. Okay, this is the shortcut for dividing. It's like the exact opposite of multiplying. When you multiplied, you added. Here, when we're dividing, we're going to subtract the exponents. 5 minus 2 is the 3. Here, 4 minus 1 is the 3. In this one, you notice the biggest one's on top. The answer is on the top of a fraction. Here, the biggest exponent is on the bottom in the denominator. So the answer, when you subtract, goes in the denominator. So how do you want to say that? The biggest exponent, where the biggest exponent is in the original problem. This also works when you got more than one thing. Is what if we just didn't have x's? What if we had like an a to the power of 2 and a b to the power of 5 over an a that I should rewrite as an a and then maybe a b to the power of 7. I don't want to write all this out, but when we do this, do each variable by itself. So it looks like a lot going on, but I'm just going to look at the a's. You have a to the power 2 over a to the power of, remember when there's no exponent, it's just a 1. A to the power 2 over a to the power 1. Subtract them. 2 minus 1, I'm subtracting the exponents. 2 minus 1 is 1. The most a's are on the top, so my answer, will go on the top. And 2 minus 1 is 1. I'll put the 1 for now just so we can see it. Now let's check out the b's. B to the power 5 and b to the power 7. The shortcut is to subtract the exponents. 7 minus 5 makes 2. And I'm going to put that in the denominator, because if you look, the biggest exponent out of these two is down in the denominator. So if I was to expand these out and cancel them, I would have leftovers down on the bottom. So my b is going to be on the bottom. So those would be my answers. A to the power 1 times b to the power of 2. Now the subtracting exponent only works for things with exponents if you have a normal number like this. I got whole numbers and then numbers with exponents. These numbers here, do these have exponents? No, so you just deal with them like you would a normal fraction. Or it's a fraction, it's a division problem. 12 over 16. Can you divide 12 by 16? No, but you can simplify it. Divide by 4. Divide by 4 makes 3 over 4. This is just the first part here. I'm not dealing with the a and the 5. Just 12 over 16. The fraction simplifies to 3 over 4. Now that you've done the numbers, these things with the exponents, let's use our shortcut because we're dividing with exponents. We'll end up subtracting. Now we're doing this part. A to the power 5 over a to the power 2. Subtract the exponents. 5 minus 2 is 3. Where am I going to put the answer? I'm going to put it on the top in the numerator because out of both of these, the biggest number is in the numerator. So that means if I was to expand these out and cancel, I would have all the leftover ones in the numerator. So I'll put an a, and then 5 minus 2 makes the 3. This is how we divide and simplify exponents.